You've heard DNS being called the phonebook of the internet, translating human-readable names into IP addresses. But that's not the whole story. The early internet already had a phonebook. It was one text file, and it broke. Every machine on the network lived on a single file called host.txt, kept on one server at Stanford Research Institute. If you wanted to add a computer, you'd have to email a human. After it was added, everyone had to download the whole file again, and until they did, their copy was simply wrong. To make things worse, when that one server went down, nothing new could be added. One machine's outage froze the entire namespace. This didn't scale. So DNS didn't build a bigger file. It asked a better question. What if nobody has to know every name? The answer was a tree with no single owner. Take mail.google.com. Read it right to left, and that's the hierarchy, with a root at the very top. Your machine asks a recursive resolver, what's the IP address for this site? The resolver asks the root server, which says, I don't know, but you can ask the .com server. .com doesn't know either, and says, go ask Google's name servers. And finally, Google's name servers hand you back the correct address. Only the last reply was an answer. The first two were directions. The root, the top-level domains, and the domains themselves are all run by different organizations. Google runs its own name servers. So Google can add 1,000 subdomains overnight, and nothing above it needs to know they exist. The nodes above only need to know who to ask next. To make things even more efficient, these addresses are cached in multiple places, so most lookups never even reach the root. This is also why a DNS change takes hours. Nothing is actually propagating, you just have to wait out the TTL on all these caches. So DNS isn't a directory that knows every name. It's a chain of referrals where nobody has to.